Okay, so let's finish up these problems. So these are all just different transformation problems, and what I'm asking you to do is to state the transformation, plot the parent function and the transformed function. So let's start with number 12. So the parent function in all of these cases are either 2 to the x or 3 to the x. So for 12, of course, it's 2 to the x. And we have two transformations. We have the exponent. So let's write this function out here. So remember, the transformations have a similar type of thing that we've had before. We've had, we would have a to the x minus h plus k. So the number in the exponent is the x shift. So we'd say x shift minus 2, y shift minus 3. So what we can do here is we can shift the axes that we use to kind of base this thing upon. So we'd move the y down 3. So we shift that down 3, and then we're going to shift the x minus 2 like that. And then we'll plot everything relative to that new coordinate system. But we'll do it lightly. So let's plot the parent function first. So you're going to have 0, 1. So remember, you put 0 in here, you're going to get 2 to the 0 power, which is 1. 2 to the first power, which is 2. 2 to the second power, which is 4. 2 to the third power, which is 8. And then you get a half, a quarter, and an eighth, and so forth. And you then have the axis as your kind of asymptote. So what we'll do is we'll draw these horizontal lines. So we'll lower this by the y by 3, and we'll shift the x by 2 in the appropriate directions. And then relative to that, we can draw the same points. So you go 0, 1, 1, 2, 2, 4, 3, 8, 2, 4, 6, 8, and then a half, a quarter, an eighth. So that would be your transformed function. So this would be g of x, and this would be f of x. Okay, let's go back and do the next one. So we've got the parent function, in this case, is 3 to the x. Actually, let's use f. So to use f, and I use g. Let's try it again. F. Okay. G of x is 3 to the x minus 3 plus 2. So again, what we're going to have is we're going to have an x shift of plus 3, because we have x minus h, and a y shift of plus 2. And we have no reflections. Okay, so now we need a piece of graph paper. Okay, so let's plot the parent function. Well, the parent function is 3 to the x, so we still have 3 to the 0 power, which is 1. We have 3 to the first power, which is 3. 3 to the second power, which is 9. And then we have 1 over 3, which is 1/3. Then we have 1/9. So quickly approaches the x-axis. Now, as far as transforming moving this thing, we're going to do an x shift to +3. So we're going to put an axis here. And if you're drawing it, you'll just use a pencil and just do it lightly. And we'll increase the y shift by 2. And then we'll plot relative to that particular new axis. So here's 0, 0. So then we'll go up 1, 0, 1, 1, 3. 2, 9 will go off the screen. Then we'll have -1, 1/3, -2, 1/9. So then you can draw that in. So this would be g of x, and this would be f of x, as far as the transformations are concerned. Okay, let's move on to the next problem. Sorry for the hesitation. I'm doing more than one thing at a time. Okay, let me grab a piece of graph paper. Okay, so the next problem is 14. So our parent function is going to be equal to 2 to the x. And then we have our transformed function, which is -2 to the x plus 1. So we have two transformations here. We have an x-axis reflection because of the negative sign in front of the 2. Remember, we're taking the additive inverse of 2. Okay, so that'll give us an x-axis reflection. And then we have a y shift of +1. So there's no x shift because we just have 2 to the x. But we do have an x-axis reflection. Okay, so we got those two. Let's reflect those in the plot. So we'll plot the parent function, which 2 to the 0 is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. And then we go 1/2, 1/4, and 1/8. So that's our parent function. Now, as far as shifting the y-axis, we're just going to shift it 1 unit like that. But what we'll do is we will reflect these points across the x-axis. So instead of going up 1 relative to this y-axis at x equals 0, we'll go down 1. Instead of going up 2, we'll go down 2. Instead of going up 4, we'll go down 4. Instead of going up 8, we'll go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the other ones will go 1/2, 1/4 as we approach that asymptote like that. So this is the original function. This is the parent function, and that's the transformed function. Okay, moving on to 15. So now we've got a negative sign in the exponent, which means that's going to be a y-axis reflection. So let's put a page in here. Okay, so we're in 15. So our parent function is going to be 3 to the x. And our transform function, what we do here is we factor out the negative sign, just like we've done previously. So negative x plus 2 is the same as negative the quantity x minus 2. So we've got two transformations. We've got a y-axis reflection, and we've got an x shift of plus 2, because we look at it after you've factored out the negative sign. Okay, so we're going to plot the parent function, which is, again, all exponential functions go through this point 0, 1. Then we go 1, 3, because it's 3 to the first power, 3 to the second power. 1/3 is 3 to the negative 1. 1/9. Okay, so that's our parent function. Now, when we do a y-axis reflection, we're going to flip across the y-axis. But first we need to shift the x in the x direction plus 2 units. So we're going to have this vertical line shifted 2. And the horizontal just stays the same. So normally we would go, since it's flipping across the y-axis, we leave that point the same. Normally we go right and up 3, but we're going to go left and up 3. We're going to go left 2 and up 9, whereas we used to go to the right 2. And then we go 1/3, 1/9. And so this is the exponential function. This is g of x, which we'll find later has what's called exponential decay. It decays instead of growth, it decays. So exponential decay always has a negative exponent. Okay, number 16, we're getting there. So again, this is going to have a y-axis reflection, but we have both an x and y shift. So our parent function is 3 to the x, and our transform function is 3 to the negative x minus 3 minus 1. Again, we factor out the negative sign. So we get 3 to the negative the quantity x plus 3 minus 1. So we have a y-axis reflection. We have an x shift of minus 3, and we have a y shift of negative 1. So we're going to plot our parent function. So it's 3 to the x, so we're going to go 3 to the 0, 3 to the first, 3 to the second, 3 to the negative 1, 3 to the negative 2. So that's our parent function. Then we're going to draw this axis that we're going to shift. We're going to shift -3 units in the x direction, -1 unit in the y direction. And then we're going to plot the points. So you can go over here to your parent function, and you saw that above the origin, well, we go 1 unit. So we get to here, just like moved from here up 1 unit. Then we go, now since we have a y-axis reflection, we're going to go left 1 and up 3, and left 2 and up 9. And I'm using the wrong color. And forgot that point. And then we'll go 1/3, 1/9. And again, this is going to be exponential decay. Except I just realized I did something wrong there. So let's undo it. It's because I did the wrong color. So we actually go down here. We shift here up 1. I had done it, I just used the wrong color. So we go 0 up 1, over 1 up 3, right? 1, 2, 3. So I did do those wrong. Okay. So we'll go from the origin up 1, over 1 from the origin up 3, 1, 2, 3. Over from the origin 2 up 9. Then we go to 1/3, 1/9, and we get this exponential decay. And we approach this asymptote. So that is g of x. And one last problem, which we've got all the transformations that we're going to look at. We're not going to do any stretching here. Okay, so last problem. Parent function is 2 to the x. Our transform function is -2, -x plus 1 plus 2. So again, we're going to factor out the negative sign in the exponent. So what we have is we have an x shift of plus 1, because we have negative the quantity x minus 1. So we add 1 there. We have a y shift of plus 2. We have an x-axis reflection from here. And we have a y-axis reflection from the negative sign in the exponent. So we're going to do the parent function, which is 2 to the x. So again, we go up, start at the origin, go up 1. They all do that. Then you have 2 to the first power, 2 to the second power, 2 to the third power. Then we go the other way, 1/2, 1/4, 1/8, approach the x-axis. So that's our parent function. And then what we're going to do here is we're going to shift these coordinate or the axes. So we're going to move the y-axis 1 unit in the x direction. And we're going to shift the y-axis 2 units in the y direction. Now, as far as plotting the points, notice here we went up 1, so we're going to go down 1 here. Then normally we would go right 1 up 2. So what we're going to do here is we're going to go left 1 down 2. Normally we go right 2 up 4. We're going to go left 2 down 4. 1, 2, 3. And then finally here we normally go right 3 up 8. We're going to go left 3 down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you go 1/2, 1/4, 1/8. And you end up with this situation where you can see we're flipped across the x-axis and y-axis.